In the previous session on the course of estimating and costing, we have studied how to determine the quantity for trapezoidal footing. In this session, we are going to study how to take out the quantities for steel reinforcement. Reinforced cement concrete. Reinforced cement concrete is a very common civil engineering item. The quantity of steel can be either determined by percentage of the gross volume of concrete, or it can also be computed separately. The various types of steel reinforcement commonly used in civil engineering construction works are plain round mild steel bars, deformed bars, cold twisted bars, and hot drawn steel wires. The various shape of reinforcement commonly observed in any of the civil engineering structure or construction is first hook and bends. Hook is a U shape provided in a steel reinforcement for anchorage or proper bonding, whereas bend is of L shape provided at the end of the straight bar or at the curved bar. Another type of the shape which is common is straight bar and curved bar. Straight bar can be a simple straight bar without hook and bend. A straight bar can also be with single hook and single bend, or a straight bar with two hooks, that is one on either side, or a straight bar with two bends, one on either sides. So in order to calculate the quantity of steel reinforcement, we need to calculate the length of each of these bar. Next, we also have binders, stirrups, links. The stirrups are of different shapes. For example, rectangular shaped stirrups. Stirrups can also be with binder. Stirrup can also be open, or stirrup can also be in square shape. So the length of a single stirrup is to be determined. Now, length of reinforcement. In order to calculate the quantity of steel reinforcement in any civil engineering work, we need to calculate, or we need to know first its mode of measurement. The mode of measurement for steel reinforcement is ton or quintal or kg. And now in order to calculate the kg or weight of the steel reinforcement, we need density of the steel reinforcement and the volume. Density of the steel reinforcement can be obtained through manufacturer, whereas the volume of the steel reinforcement depends upon its cross-sectional area and the length. Cross-sectional area is computed through the diameter of the reinforcement. So in order to compute volume, we need only the length, and the length for the various types of or shapes of stirrups or reinforcement is to be determined. So the main aim in calculating the quantity of steel reinforcement is to calculate first the length of various types of reinforcement. So in this, we'll calculate first the length of hook and bend. Hook is a U-shape element which is provided at the end of straight bar, where bend is the L-shaped element which is provided at the end of straight bar. The length which has to be added to the straight bar length for hook and bend depends upon the value of K, where K depends upon the type of steel or the type of reinforcement. For mild steel having diameter of the bar less than 25 mm, K is equal to 2. For medium tensile steel having diameter of the bar less than 25 mm, value of K is 3, and for cold work steel value of K is 4. Similarly, when the diameter of the bar is about 25 mm, the value of K is 3, 4 and 6 respectively. And based on the value of K, we have the length of hook and length of bend. When the value of K is 2, length of hook is equal to 9d and the corresponding length of bend is 5d, where d is the nominal diameter of bar. Similarly, when K is equal to 3, length of hook is equal to 11d and length of bend is 5.5d. When the value of k is 4, the provision for the length of hook is provided as 13d and the length of band is 6d. Similarly, for k equal to 6, length of hook should be 17d or the length of bend is 7d. In no case, the length of hook and bend should be less than 75 mm. Now this is the length which is provided for the cutting of the reinforcement. So for hook and bend, minimum 75 mm additional length is to be provided in the straight bar so as to make hook or bend. Similarly, length of straight bar can be determined as for simple straight bar the same would be as given on the drawing. When there is an hook, it would be L plus H. H is the length of hook and we determine length of hook as per we have studied in the previous slide. Similarly, length of bar with two hooks, the length would be L plus 2H. And when there is a bend, when there is only a single bend or a bend is provided at only one end of the straight bar, length of the straight bar with bend would be L plus B. That is B is the length of bend or the provision in for length of bend. When there are two bend, one on either side, the length would be L plus 2B. In this diagram, H represents the hook and B represents the bend. Similarly, the length of binder, stirrups and link is as calculated for rectangular stirrup with hook. Length of single stirrup is equal to 2 into A plus E plus 24D, where A is the vertical distance measured from the center to center of the stirrup reinforcement, where E is the horizontal distance measured from the center to center of the reinforcement. Similarly, for rectangular stirrups without hook, the length is equal to 2 into A plus E plus 20D. For partially open stirrup, length of a single stirrup is equal to 2A plus E plus 28D. Stirrup with bend, the length of single reinforcement is equal to 2A plus E plus C plus 12D plus B. In this type of stirrup, we also have a bend and a hook. Whereas when we don't have a hook, the length of a single stirrup is equal to 2A plus E plus C plus 9D plus B. Similarly, for shaped stirrups, length of a single stirrup would be 4C plus 24D. We'll solve a numerical to determine how to calculate the quantity of steel reinforcement. Now, we need to determine the quantity of steel reinforcement for a beam. A beam having a clear span of 4000 mm and support width of 230 mm. Now this beam composed of reinforcement item 1, 2 and 3. We need to calculate the quantity of steel reinforcement of item 1, 2 and 3. Item 1 is the top reinforcement, item number 2 is the bottom reinforcement and item 3 is the stirrups. Stirrups are provided at a center to center distance of 180 mm. It can be observed through cross section. The beam has the width of 230 mm and the overall depth or the total depth of the beam is 375 mm and the cover on all sides to the reinforcement is 40 mm, and we need to calculate the weight of this reinforcement. So in order to calculate the weight of the reinforcement, first of all we need to calculate the volume, and in order to calculate the volume we need to know the length of each of these bar. So we'll calculate the length of the straight bar, that is item 1, length of straight bar with bend. This bar has a bend at both ends, and similarly length of single stirrup, that is item number 3, and this length of single stirrup or single item would be multiplied with the number so as to get the total length. So length of straight bar, length of single straight bar is equal to total length of beam minus 2 times cover. So total length, which is equal to 4000 plus 230 on either sides minus 2 times cover, that is cover width is 40 mm. One cover on this side and another on the other side. So the length of a single straight bar is 4380 mm, and the number of straight bars are two numbers. Similarly, we'll calculate the length of straight bar with bend, that is item 2. So the length of single straight bar with bend is equal to total length minus 2 times cover plus 2 times the length of bend, that is this L portion. Now this is taken as corresponding to K value of 2, 5D. Total length of beam is equal to 4000 plus 230, that is support width on both sides, minus 2 into cover. Cover is 40 mm on all sides, plus 2 into provision for bend, which is equal to 5D. 2 is used as two bends are there, one on each side. So the length of single straight bar with bend is calculated as 4580 mm, and the numbers of straight bar with bend is two numbers. Similarly, we'll calculate the length of single stirrup. The length of single stirrup is calculated based on the shape of the stirrup. Here the stirrup is of rectangular shape with hook, and so the length of a single stirrup is equal to 2 into A plus E plus 24D. 24D is the provision for hook, A is the vertical distance of the stirrup measured from center to center of the bar diameter, whereas A is the horizontal distance measured from center to center of the bar diameter. So first of all, we'll calculate A and E. A is equal to total depth minus 2 times cover minus 2 into half the diameter of the stirrup reinforcement. So 2 is used for on both sides. Total depth of the total depth of the beam is 375 mm, 375 mm minus 2 times the cover. Cover is 40 mm minus 2 into half of the diameter of reinforcement used for stirrup. The diameter of stirrup reinforcement considered here is 10 mm. So 2 into 0.5 into 10. So A comes out to be 285 mm. Similarly, we'll calculate E. E is equal to total width minus 2 into cover minus 2 into 0.5 D. The total width of the beam is 230 mm minus 2 into 40 minus 2 into 0.5 into 10. So E comes out to be 140 mm. We'll substitute this value of A and E in this equation and would calculate the length of single stirrup. So the length of single stirrup is equal to 2 into A plus E plus 24D. We have 2 into 285 plus 140 plus 24 into 10, that is the diameter of stirrup reinforcement. So the length of single stirrup reinforcement is 1090 mm, and the numbers of stirrups in this beam are 4000 plus 230. As it is provided center to center, we would take the length or the span as center to center span. So clear span 4000 plus half the width of the support on this side plus half the width of the support on another side. So it gives 4000 plus 230 divided by the 180, which is the spacing of reinforcement. So the numbers of stirrups comes out to be 24 numbers. Now we have calculated the length of all the items of steel reinforcement in a beam. We need to multiply this with the area and the density so as to get this in terms of weight. So total quantity, which is equal to, for item 1, length of single bar is 4.38 meter, diameter of the bar is 10 mm, and the number is 2 here, that is the top bar. So the total length is equal to 2 into length of single bar, that is 4.38. So the total length of the top bar is 8.76, and this is multiplied with the density of the steel, which is used as 7850 kg per meter cube. So the weight of the top bar is 5.4 kg. Similarly, the weight of bottom bar is calculated in item 2. The length of single bottom bar, that is straight bar with band, is calculated as 4.58 meter. Diameter of the bottom bar given is 20 mm, and the numbers of bottom bar are 2. So the total length of the bottom bar is 2 into 4.58, which is equal to 9.16, and this is multiplied with the area and the density of the steel. So the weight of the bottom reinforcement is 22.58 kg. Similarly, we'll calculate the weight of steel reinforcement in item 3. The length of single stirrup is equal to 1.09. The diameter of stirrup reinforcement is 10 mm, which is given here. The number of stirrups used in this beam are 24. So the total length of the stirrup reinforcement is calculated as 24 into 1.09, which is equal to 26.16. And this 26.16 is multiplied with the density and area of the stirrup reinforcement. So the weight of stirrup reinforcement is 16.12 kg, and the total quantity of the steel to be used in the construction of this beam is equal to sum of the weight for item 1, item 2 and item 3. So the total weight of the steel reinforcement is 44.10 kg. In this way, we calculate the quantity of steel reinforcement for a particular civil engineering item. Thank you.